Your object distance equaling 4 centimeters. Okay?
Focal length
and
3 centimeters.
Your object height
Optic length 4 centimeters.
equals 0.5 centimeters. Those are the measurements you're given. Then you did the Lensmaker's equation,
Yeah.
1 over d sub O plus 1 over d sub I equals 1 over F.
Don't mind that.
You plugged in 4 centimeters for d sub O and 3 centimeters for F, and you ended up with a d sub I equaling 12 centimeters. Great. Then you use the magnification equation.
Yeah.
The magnification equation, which gives you the ratio of the image height over the object height, and that's equal to negative d sub I over d sub O. Well, that ends up being negative 12 over 3, negative 12 centimeters over 3 centimeters. So you got a magnification of negative 4. That means your image height is going to be 4 times bigger than your object height. What's that? Oh, dang. Holy
Oh,
I'm so
scratch
glad
that.
I'm being videotaped.
Scratch
I gotta
that.
tell you, it's really kind of freaking me out. I've never. Oh, I knew what the answer was. Okay, so you get a magnification of negative 4.
No.
It's 3. The
It's
bottom's
3.
4.
It's
The
4.
bottom's 4.
The bottom's 4, okay?
There you go.
This is the final answer.
Okay.
Final
So,
answer.
so I want you to get that conceptually,
Final answer.
the magnification being negative 3 tells me, number 1, the image height is going to be 3 times bigger than the object height, and number 2, the negative tells me the image is going to be inverted. So I'm going to get an enlarged, inverted image. Okay, so in fact, I can actually find what that image height is, because the object height is 0.5 centimeters, and that's going to equal the magnification, which is negative 3, so you get an image height of negative 1.5 centimeters. Next, you do your ray drawing and measure d sub I and measure h sub I and hope that they match up. And let me ask you, how many people here, when they made the ray drawing, they got a d sub I somewhere between 10 and 14?
I got excellence.
Everyone in the
Okay, then
class.
you guys are awesome, you know, because I'll tell you, there's a few areas of uncertainty. There are a few areas of error. Number 1, we're depending upon your ability to draw a parallel line. And not everybody can make a line parallel to another line. Number 1. Number 2, there's another problem here, and you may have learned about this in Algebra 2. When parallel rays hit a curved surface, it is not a circle that makes all the rays come together and pass through one point, which we call the focus. Do you remember what the actual shape is that these parallel rays would hit and then go through a common point, the focus? What's that? No, not a prism. Yeah, a parabola. A parabola. Spherical mirrors are incredibly easy to manufacture. It's very easy to fabricate a spherical mirror. It's very hard to fabricate a parabolic mirror. But it is the parabolic mirror that gives you the perfect image location, not the spherical mirror. So you get a little bit of what we call spherical aberration. Spherical aberration. Is that how you spell aberration?
If you're watching this at home, you can always Google this.
No, I just can't remember how many B's and how many R's there are in
There's
aberration.
2 R's. I think that's right.
Is it 1 R, 2 R's?
2.
2 R's, okay, exactly. Some people are really good spellers, but spherical aberration, your image is not going to be perfect because the spherical mirror would need to be parabolic. Only a parabolic mirror has parallel rays passing through focus. not a spherical mirror. A spherical mirror is close. It's a lot like a parabolic mirror, but it's not precise. That's why when you guys made your solar cookers, if you made a solar cooker when you were in second year algebra, you used parabolic mirrors, parabolic reflectors, not spherical. Okay, then let's go on.
Where's
I'd like everyone now to please look at problem number 2, P2. Please use Lensmaker's equation and magnification equation to do P2. Please do that now.